Welcome to another episode of the Mapscaping Podcast. My name is Daniel and this is a podcast for the geospatial community. Today on the podcast we're discussing entity resolution for places data, why you might want to do that, and what any of this has to do with $1 Unix time, and the idea that if data really is driving innovation, join keys are going to become more valuable. To help me do all that, I've invited Auren Hoffman to be a guest today. Auren is the CEO of SafeGraph. SafeGraph has been featured on this podcast before, and I'll put links to that in the show notes. And he's also one of the driving forces behind something called Placekey. It's worth noting that I ask all organizations that are featured on this podcast to help cover the cost of producing and promoting their episode. Not all of them say yes, but SafeGraph did, and I really, really appreciate their support. It's companies like SafeGraph that make this podcast possible. So thank you very much. Hey, Auren. Welcome to the podcast. It's a real pleasure to have you here. I've seen you around online so much. I've even been involved in one of your events that we'll talk about later on. So it's great to have you here in person, or not in person, but virtually, and talk with you. You are the CEO of something called SafeGraph, and you're also a podcast host like me. Your podcast is called World of DAS. Before we dive into the conversation today, can you just put some more words around that introduction, please? Well, what is SafeGraph? Why did you start a podcast? How did you get here?
Well, first, I'm happy to be here. I'm a huge fan of your podcast. I listen to it religiously. So thank you again for having me as a guest. As mentioned, my name is Auren Hoffman, CEO of SafeGraph. We sell very boring point of interest data. So if you want to learn about Italian restaurants near me and where those Italian restaurants are and what their store hours are and the polygons of those restaurants, that's the type of data that SafeGraph puts together and sells. Very, very high veracity data. And then, as you mentioned, nowadays everyone has to have a podcast. So also do a podcast called World of DAS, where we dive into data as a service businesses and why they're interesting, and talk to different folks who are either running those businesses or consuming data from those businesses or investing in those businesses.
Would you mind, did you have some sort of interest in spatial before you started SafeGraph? How did you end up working with POI data, so points of interest data?
I think like everybody who's kind of nerdy, you were interested in maps as a kid, and probably a lot of nerds probably a lot of the folks who are listening had maps on their walls and was just always like into maps. And certainly I was one of those kids and always was into, didn't do it as a career for a long time. So got into it a little later in a career, but always had an extreme interest in maps and data around maps.
The main focus of this conversation today is help people understand this thing called Placekey. Maybe we could move off and talk about that now. So what is Placekey, and how does it relate to your work at SafeGraph, for example, or DAS, Data as a Service?
Placekey is an open and easy way to match data about physical places. So that does include things with an address or a point of interest, which could be like a name and address. And Placekey is just entity resolution for these physical places. So it allows matching, syncing, merging, deduping data on physical places. It's a super simple service that takes an input like an address fragment or a location name with an address fragment, and then outputs a simple string, which we call Placekey, and it allows data to be super easily joined with one another.
Are you in some ways scratching your own itch? I mean, you have a points of interest service, a business based around that.
Yeah, that's exactly right. One of the big problems that SafeGraph has is companies buy our data, and then they often have to match the SafeGraph data to their own data and maybe many other data sets that they're either buying or could be free data sets that they're downloading. And they have to match all these data sets together. The more they can match them, the more valuable our data is, because the more it will be put in production, the more they'll get use out of it, et cetera. If they can't match it, and before Placekey, we had scenarios where someone would say, "Hey, you don't have Joe's Deli in the data that you sent me." And we're like, "No, clearly we sent you Joe's Deli. It's right here." And it's just they weren't able to match it to their data, and then therefore they weren't able to use it. So matching is a very, very, very hard problem. It's a very big problem. And the more we can match data together, the more valuable all the data sets become.
And just so I'm clear, this is you're matching on addresses. So I need an address to be able to generate a Placekey, or can I generate Placekeys for anything in the world?
No, today you need some sort of fragment of an address, some sort of street address, some sort of understanding of that place with spatial. In the future, you might be able to do with other things, but today, an address. An address could be like the name of the place in the city, state, zip code, or something like that. So there could be different ways of describing a place, so like Disneyland or something, but you generally need some sort of either address or name of the place.
Yeah, that's. I'm glad you mentioned that description because when I look at a place key code, it's got the what and the where. So the what separated by an at sign, and then the where. So we've got the what and the location. Like, what is that description? Is it like Disney? Is Disney encoded in that string there that I'm getting, or is it a category that it belongs to? Can you explain what the what bit is?
Sure. So place key is a simple string. It's a simple key, and it's got two components, as you mentioned, a what and a where. The where is just a hash. So it's based on the H3 system that that Uber created. It's very simple to use, and it just basically gives you a sense. You could just have a key, but it just gives you a sense of just like roughly spatially where that key is, just to make it a little bit easier if you're going to perform operations on that or kind of like do nearest neighbor or do other types of things. It makes it just really easy to do that. You don't have to like look up other stuff. And then the what part is just think of it as just a general hash. It's just a encoding, and it's unique. It allows that particular place. Again, you could have Joe's pizza shop at 555 North Main Street, Suite A, or something like that, and that should have a slightly different what part than the barber shop next door or the nail salon.
It sounds like a hard problem to solve, and I know this because addresses are really, really hard. And right at the start of the conversation there, you were saying you can show up with, a complete address, like a part of an address, and we'll try and fix the problem. But this is a big problem that you're trying to solve. Can you give myself and the listeners some ideas of some of the corner cases that you've seen along the way, just to give us an understanding of how difficult this is?
Yeah, it's a freaking hard problem. It's incredibly hard and incredibly frustrating because you'll never solve it. For instance, addresses have tons of permutations. We all know that. You can have North Main Street, you could have N dot Main Street, you could have ST, you can have Suite 504, number 504, NO 504. Right? We all know those types of things, but they're also misspelled all the time. And so you can, Main Street is often spelled Mian Street, Mian Street. That's a common misspelling. But there's probably some places in the world where they actually do have a Mian Street. So most times where you see a Mian Street, it is Main Street. But in some cases, a Mian Street is actually legit. And so making sure you do that match is extremely tricky.
This might be a naive question, but do large language models solve any of these problems?
It certainly can make it easier, and there's certainly benefit, and they benefit Placekey. The thing is, as you use these large language models at scale, they are pretty expensive to use,
Yeah.
and Placekey is incredibly cheap. And so internally, like we run it and we try to run it the goal is to get, for most people, is to use it for free. You can go right now to placekey.io and start using it for free. For almost all users, they can use it for free and they're under the limits. And so we try to run it as cheaply as possible. It's a service. And if you're hitting a large language model with every single query, that's going to be really, really, really expensive. If you're using it on the back end in batch to help you figure out corner cases and write rules around those corner cases as we do, then it becomes much more cost effective.
So I can see the benefit of this being able to match data. I've been in this position myself, working for a utilities company and trying to match these data sets and having to build my own keys and having to rebuild them all the time, essentially. And
Yeah.
it just gets in the way of the work that I actually wanted to do. So I understand the benefit, not at the scale you do, but I understand the benefit from based on my own experience. And it's hard, but I can also see that it's really really hard. So it sounds hard. There's a billion different corner cases, and it's expensive. And there's things out there in the world like plus codes and what three words. I'm not critiquing your system, but why is Placekey better than these existing systems? Why build this from scratch?
Yeah, there's basically, if you think of like a way of joining data, there's kind of like two axes to think about. One is like how closed or open is this ability to join data? And then the second is how static is that? And then how much of a service is it? So can I actually use it to join? There are some services out there that are just very closed. Either they're just like super expensive or you have to go through them every time you want to do a join data. You're not allowed to like store it and use it in an easy way. And then there's also things that are just like extremely static. So if you have data and you want to, and it's slightly misspelled, like they don't have a service that can help you actually, like that Meehan Street example. You can't ping it with that and actually get, so you can't use like real data to actually code it. So the code itself, like the place key itself, is the easy part. That's like 3 to 5% of the solution. I mean, it's not totally trivial to do, but it's relatively easy. So creating an actual key that works and that unique, that's the simple part. The hard part is being able to match it with all the corner cases. That is just an extremely frustrating thing that just you have to do thousands and thousands of thousands over time, hundreds of thousands of little corner cases, solve for them. People have to report bugs and you have to get better over time. And, just getting to 99% is just not good enough. So you have to constantly get better and better and better so that people can use it and rely on it.
Yeah, that makes a lot of sense. You mentioned before being able to store these IDs. This is also true for Placekey, I believe. I can store IDs.
Yeah, that's the beauty. It's completely open. So you can take the ID, you can store it, you can use it, you can transfer it to anybody. This is not something where you have to like pay a toll every time you use it. So you can use it as much as you want. It's really easy. If somebody else has already pre-computed their data with a place key, as many, many folks do, then you can join it with your data easily offline, very, very, very simply, because it's just basically comparing two exact strings. It's super easy to merge the data. And if somebody hasn't, then you can just hit the API with it.
What does that mean for updating things? Addresses are dynamic in a lot of sense, especially the what part of it. That could change throughout time. And as new subdivisions come online, for want of a better way of describing it, or buildings are torn down, maybe sections are split up, and we see the addresses change. How do I know my stored place key needs to be updated, or is it just a matter of running the entire thing through the API again, at a regular interval?
Yeah, it's probably good to do that at least, once or twice a year or something, because not only do things change in real life, but also we've solved new bugs. And so, we've merged place keys or we've demerged things. We've done other types of things over time. So the system gets better every single day. And so it does make sense that over time, it makes sense to redo your place key every once in a while.
So we've talked about some of these corner cases, but let's talk about like some of the solutions you're helping create. Are there any interesting use cases that spring to mind? What people are doing with it? How they're using Placekey to join these data sets to ask questions they couldn't before, find answers that weren't possible to get at before?
Yeah, there's a lot of different types. So one of the most common users right now of Place Key are companies in real estate, and these can be residential real estate, commercial real estate, like multiple listing services. And they get a ton of data from a lot of different places, including from the realtors and other places like that. Some of the data is like handwritten sometimes or hand keyed in, and then they're bringing in tons of government data, city data, et cetera. And they have to merge all these data sets together, and it's incredibly complex. And so using Placekey is really, really easy for them. Another example that we see a lot are health tech companies and kind of health providers. So they're bringing in a lot of data. Like in the US, there's this free file from Medicare called the NPI file. And it's a super messy file, but it's a really valuable file. And they have got a lot of other data. They may have data from like providers, from doctors, from other types of things. And they're trying to merge that data together so that they could say this doctor is this other doctor, this MRI imaging center is this other MRI imaging center, this hospital is this other hospital, and being able to, like, none of that data lives in one place. So data about the effectiveness of a hospital and the cost of the hospital and a bunch of other things about the hospital might live in many, many, many different data sets. And so merging that data together using Placekey is super helpful. Would it be helpful to go over some other ones as well? Or
I think it'd be really interesting to hear about what opportunities do you see that people haven't like explored yet, or you don't see them using it often in that situation. Because sometimes when you work on this kind of stuff and you're really close to it, and of course you come to this with all your experience from SafeGraph as well. Are there any other sort of really obvious big wins you can see out there that people are perhaps not yet taking advantage of?
I'll tell you some where lots of people are taking advantage, but it probably could get more. So cities and counties are releasing data, and they have great data on their website. If you go to the San Francisco website or something that has some incredible data about physical places. every single one of their data sets has a different ID. They're not joinable today. They don't give you pre-joinable data. And it makes sense that there's a tax assessor record somewhere and a health record somewhere else, et cetera. That data should come with a common ID that's joinable. And we're starting to see more cities and counties use Placekey internally to join data. And I think very soon you'll start seeing more of them put the Placekeys on their data so that the data is easily joinable. And that makes it great for everybody to use, whether it's a academic who's using the data or a company or a researcher or the cities themselves to benefit more from that data being joined.
Could you put some numbers around this? Like, I know you have an API that people can use to get at to create their own place keys programmatically based on addresses or pieces of addresses. Like, give us an idea of the traffic so we have a bit of an understanding of how many place keys are out there in the wild now that are being used.
How many total Placekeys there are?
Yeah, or it'd be really helpful, I think, if we had some sort of idea of how big this thing is. It's one thing if two, three big organizations are using it. It's another if we're talking like hundreds, 500, 10,000 organizations that are using this system today.
There's roughly tens of thousands, maybe roughly a little over 10,000 organizations that are using Placekey today. And then there are over 1 billion Placekeys today.
Place keys that have been generated.
Correct.
Wow. Okay, thanks. So let's talk about how we create one. If I did this the other day, I went to placekey.io, and then I was I'm not a developer, or not the developer that you are, and a lot of people listening to this are. So you've got this little widget on the website, generate a place key. I can plug in an address and got a place key. I can see a hexagon on the map that's also generated. So I think you mentioned before, H3 has got to be is a part of this somewhere in the system.
Yep, exactly. So it's based on H3, which I love. So I love just like hex systems in general. They're they're so easy to use, and just spatially just makes everything so much easier. Squares have problems with having different distances from other squares, and so the hex is just a really, really nice system. So I think that's just a great piece of open source architecture that Uber developed.
And in terms of the actual API, what do I need to do to use that?
API is super simple. You just get a key, and then you could use it in any way you normally use an API, and you ping an address. It could be a fragment of an address or a place and an address. So a name of a place like a McDonald's or something like that. And you get back your place key. So it's super easy. And then if you have lots of data, especially like data from maybe multiple sources that you want to join, you just ping each piece of data, you get the place keys, and then you can join that data really, really easily.
Are you fixing my address along the way? So I'm getting a place key back, but can I use that somehow to fix my address? Because I've got half of an address, right? And you can give me a place key for that. Can I go the other way and get a fixed, correct address back off this?
Not today. It is something that a lot of folks using the place key have asked for. It's not what we're focused on today. Today, we're really just focused on this kind of like matching, deduping, merging, syncing, this kind of core entity resolution problem. It might be something we do in the future, but we're really just focused on how to merge and sync data today.
It makes a lot of sense to be focused. And please don't interpret any of this as critiques. I'm just curious. You mentioned free. You might have also mentioned a price along the way. I mean, people can obviously see this on the website, but for those listening to the podcast, what is the cost of this?
As low cost as possible. So if you're pinging Placekey 10,000 times a day or less, it's free. So basically 300,000 times a month, it's free forever. You can use it as much as you want, et cetera, during in that world. And that is the vast majority of use cases fall within that. For people who are pinging Placekey more than that, they're doing more of those queries per month. We just ask for some sort of small fee to essentially cover all the API costs, the compute costs, et cetera. So those fees, are really about companies and organizations that can afford to pay, and they're generally paying, somewhere between, let's say, $2,000 a year and $50,000 a year to help defray and cover the server costs.
And it also adds sustainability into this, right? Because if it's a loss leader for you guys, it sounds like a big lift to create this, develop this, and keep working on it. If it's a loss leader for you, if you're constantly losing money, if you can't cover the costs, it doesn't sound sustainable. And if this system isn't sustainable, the value just kind of drains out of it, at least in my mind.
Yeah, that's right. And if we consider the engineering effort internally, it is a loss leader for us today. but the goal would be at least for it to break even over time and cover those costs.
Is there any part of you that just wishes somebody else had done this? It sounds like a lot of work.
I 100% wish somebody else did this. If I had known how hard it was, we started Placekey 3 years ago. If I had known how hard the journey was and how difficult, like, just every single corner case was, we would have never done it. It is incredibly difficult to do, and I wish somebody else has done it and we could just use what they did. That would have been amazing. And so I hope that the hard work that we've put in will benefit everybody who cares about data. And these join keys and data are so important. They make every piece of data more valuable, and they make all the learning that you could do on that data so much more powerful.
Yeah, in a previous conversation, this wasn't you said this actually. You said if data really is driving innovation, join keys are going to become more important. Could you tell us more about that, please?
Yeah, so join keys are a way of putting data together and making that data more valuable. No one data set has even a small amount of all of the world's data. And so if you're going to ask questions that are interesting today, you often have to ask them across multiple data sets. And the only way to do that effectively is by joining those data sets together. And there's lots of join keys in the world. And these join keys, sometimes we don't think of them as join keys, but there are all these different join keys that allow us to join data effectively. So one of the most common ones that we use is the dollar. It's not the best join key, but it's the join key that generally people use to assign some sort of value to something. And they may use a dollar even in a certain point in time. So they might use a current dollar, or they might use a dollar from 1991 or something like that to use to join data that's like somewhat historical. And even if you're mainly transacting in euros or you're mainly transacting in rubles or whatever, you need some sort of way of simple join key to understand the value to put that together. Time is another join key that we use. So many people who are listening to this podcast will be familiar with Unix time. Unix time is a very simple integer that's based on like the number of seconds since January 1st, 1970. Again, totally random, totally weird, like not the most ideal kind of thing. And that's the thing with join keys. They're never perfect. If you're looking for the perfect join key, you will never get one. So they all have some weird imperfection that's out there, and they're hard to get started. Sometimes you can get them started because you're like the emperor of Europe. Like that's how the meter got started. So Napoleon, right? Napoleon was the emperor of Europe, and he just decreed that everyone use the meter. And I don't know, I guess your head would get chopped off if you didn't do it. So you probably are like, okay, I'll use the meter because I don't want my head to get chopped. That is not something that's at most of our disposals. We're not the emperor of a very large landmass. And so we have to convince people in other ways to do it. We have to show the utility. We have to make that data easy to use. We have to make it as low cost as possible. There are all these other ways to help people use our join keys.
So at this point in the conversation, I'm wondering if you're arguing for join keys or for dictatorships. I'm not sure.
Definitely for join keys.
Okay, great. Great. I'm glad we clarified that. So you talked about this huge sort of engineering effort that goes into this thing, and it's understandable with all these edge cases, trying to figure out what part of this address is. I don't have the complete picture, and even if you did have the complete address, it's not always easy. I get that. Is there any part of this that the community could solve? So we see OpenStreetMap is a great example of this. The community is fixing things, adding things, updating things. Is this a possibility for an open system like Placekey?
It's different, but yes. In Placekey, the way it gets better for everybody is every time everybody pings it, it starts to learn. And it says, oh, it might learn like this is a different type of misspelling, or this is a different type of input for this. And it starts to get better at these corner cases. Sometimes it gets better immediately. So somebody pings and it can get better immediately. But we're also running these like jobs in batch every week to have it learn from everybody else, and things that didn't match, or we're trying to figure out what should have matched, et cetera. And so the more people that ping it, the better it gets. In addition, the more people that ping it, the more bugs that we see. So people are very, very good about telling us when there's bugs. And we have bugs all the time because this is a really, really, really hard problem. And we don't ask people to have to go to some sort of form somewhere and fill out 20 clicks to fill out a bug. They could just send it to support@placekey.io and they can send it any way they want. And we will read it. We will convert that internally into a ticket and we will work on it. And sometimes if it's like an important ticket, like we will get it done that day. That's how fast we're trying to work on all of these different things. So we're reading every single thing that comes in and we're trying to make it better really, really, really quickly. We might be prioritizing tickets from paid users faster than non-paid. So that's maybe one of the benefits of somebody who might pay. But we're getting to every ticket that's out there and we're looking at every single thing and every single corner case. The more bugs that we get, the better it gets for everybody. It just doesn't solve the problem for that one user. It solves it for every user.
And I'm sure you've thought of this, but if I was trying to spread an idea like Placekey, get more people to use it, build on this network effect that you've already created, I would be trying really hard to get it into, foundational data sets, perhaps like OpenStreetMap, Overture, some of these big building footprint data sets that are coming out there. Is there a world where that is possible?
Definitely. Yeah. So that's part of our goal is to be able to do that. You want to do that with the community's assent. And some of these systems that are out there, some of these data sets have very, very, very strong communities attached to them. So you don't want to just do it without bringing people along and showing them the benefit of that. But that's one of the things is like joining these data sets together. If you want to join OpenStreetMaps and open addresses and Overture, if you want to take those three sets, which have a lot of duplicate data, and you want to join them together, today it is a massive engineering effort to do. With Placekey, it's super easy.
When people push back on this, what do they say? Like, there's nothing that's for everyone. And when I joined your launch event, I think it was 3 years ago. Yeah, I was really excited about it. And, posted about I'm going to be part of this thing. It's interesting. It's new. And someone showed up on Twitter and just cut me off at the knees. I can't remember exactly what they said, but it was something like, "It'll never work. It's never been done, or people tried before." So something along those lines. Like when people push back on that, what do you say?
I think they pushed back legitimately. We had no idea how hard it was going to be. It is a much, much harder challenge than we thought. We thought, oh, that's few smart engineers and few months, we should be able to solve this problem. Like it turns out to be a much, much, much harder problem than that. And it's a slog. And then, of course, as you start to get outside the US, we start in the US, as you start to get outside the US, you have all these other things. If you start to, we start in English, you start to get outside of English, and then now you start to get outside of Latin characters. You have a whole other issue. It's a never ending thing that you want to solve. Doing this entity matching is super, super, super hard. And the only way you can get better is by seeing the scars and just slowly, it's like a series of like millions and millions of cuts that you have to put Band-Aids on. And it just takes a long time to get better at it.
Oh, but you have such a like romantic way with words. You make it sound like something I really want to be part of, being kicked to death by grasshoppers. If you could go back in time, what would you tell yourself? Because you've learned a bunch of lessons on the way, and maybe the lesson was just, oh, this is much harder than I thought it was going to be. But have there been any learnings on the way where you're like, once we figured that out, we saved ourselves a lot of time? That was like a jump.
Well, one of the things I think this is probably true of most tech systems that anyone has done is like simplicity is the most important principle. Adding complexity, you want to add it slowly. If you add complexity too quickly, it makes everything much harder, it makes the development harder. And every time we added like a lot of complexity ahead of need, that was a mistake.
Okay, in need, so this is customers or people using the system saying, "Oh, look, I'm just focusing on English right now. I'm just focusing on these states, maybe in the US." Is that when you say need? Is that what you're talking about?
That's part of it, but also just like you could come up with your own corner cases pretty easily, but if you don't see them in the wild, if you don't see actually people pinging you with those, maybe they're not the most important things to fix.
Makes a lot of sense. Do you think there's any part of this? You've talked about the openness of it. Anyone can use it and store these things, which is great. Could this have moved any faster if it was closed? If it was like, we own the system, the knowledge is ours?
There's always trade-offs on these things. And so it's possible sometimes it could move faster, but then maybe it stalls out later. So we're building something that our goal is to have this stay on well past the life of our company, well past the life of even ourselves. If you think of the meter or Unix timer, some of these other things that are out there, we want this to stay for an extremely long time, and we're building it that way. And you can't do that if it's like a completely closed system.
So there'll be other people that are trying to build something like, like this, something bigger than themselves that's going to outlast them and their business. And you've mentioned a few of the things that you're doing because that's the goal. Let's say I'm doing this too, just in a different vertical. What recommendations would you make to me? What advice would you have for someone like me?
In terms of like creating a join key.
In terms of creating a thing, like a tech, or in terms of creating something that I'm going to put into the world that I want to outlast me. Like there must be some sort of overarching principles that you think about.
Well, one thing is just how useful is it, right? And so if you think of these things that, that are, and it could be a work of art that we all have benefited from, or Shakespeare's plays or something like that, right? These are things that are incredibly useful and have outlasted the authors. In some cases, we benefit from things we don't even know who the authors are or who they were. It could be a bridge or something like that that was created many hundreds of years ago, or a road, or some other type of structure or something like that. We don't know who built it, but we benefit from it every day. And they may have built it for public consumption. It's not like their heirs are benefiting every time you walk on the road or something like that. So really, just to me, the most important thing is like, can you make something that is useful to people and that people really benefit from? And will they continue using it even if you're not directly involved in it?
Yeah, and I think you're probably with Placekey, this idea of joining data. It's unlikely that it's going to go away. That the problem is going to go away in the future. We're always creating more data. It's not like we're done now. We have all the data we need once we've figured out how to join it. It's over. We're collecting more and more than ever before. So I can see this being relevant, for a long time in the future, if not forever.
Yeah, and joining data sets, the questions that we want to ask these data sets, the biggest problem today is that all of this data is siloed. Even if the data is free, it's effectively siloed because it's too hard to join. And so you're really just working with a very, very limited data set that has a limited, if you think of data as rows and columns, it has a limited number of rows and a limited number of columns that are out there. And the real power comes from being able to ask deep, deep penetrating questions across data sets. And the only way to do that is by joining that data. And you mentioned LLMs earlier. With LLMs, this becomes even more important on being able to put this data together and being able to really dive in, especially because, in many cases, this data is the arbiter of truth. And you want to be able to get back somewhere to be able to prove something is true.
It's interesting. It makes me think of data interoperability as the ability to join it. And yeah, and it sounds like a really sort of stupid realization. But up until now, I've been thinking about data interoperability as, can it be consumed by another system? Is it in the right file format? Is it in an open standard? But yeah, if it's can be consumed by another system in an open format, but can't be joined with something else, is it truly interoperable?
Yeah, exactly. And sometimes people play with that. So they say, oh, yeah, our data is, interoperable, but there's no way of actually joining that data. There's no key, or the data is hashed, or it's very hard to understand, or it needs to be processed in a weird way or something like that. So the more that we can join these data sets together, and Placekey is a join key. So if you think of data, it's really about four nouns, right? It's data about people, data about places. That's really what Placekey focuses on. There's data about like organizations or companies, and there's data about products. So those are the four nouns. Almost all the data is about one of those four nouns. And then, of course, they can be crossed with each other. They can be crossed with time, with price, with many other types of things that are out there. And the more that we can create join keys so that they can be crossed with each other, combine with each other, dedupe with each other, the more questions that we can ask of this data.
Yeah, we've this is great. We've come a long way. It's kind of opened my eyes to to obviously how difficult this problem is and how difficult it's going to be in the future. That was a very subtle segue into the like, what does the future look like question. You mentioned before about English, other languages, other geographies, but I'll hand the mic over to you now. What does the future of this look like? Where are we going? What does the dream scenario look like for you and Placekey?
Yeah, there's kind of a short-term scenario and a more longer term. So short-term, the goal is to be able to cover any place that could be represented with an address in the world. So basically some place you could send a letter to or something like that would be an example of a place like that. That place, you should be able to resolve into a place key, have a place key, be able to join with place keys. And again, that place could have just an address or it could have a name and some sort of fragment of an address or something. So that's the short-term goal. And the goal is to be able to do that every single place in the world, even a place like North Korea, and in any type of language and any type of characters. Some of that can be done today, and that's really exciting. Some of that, like with non-Latin characters, is something that I think will get done in sometime in 2024. But that's happening, and that's happening in the short to midterm.
Wow, I just got to stop you there for a second, and I want people to recognize that that's a very big goal in the short term. I honestly thought you'd say something like that for your long term, so I'm interested now to hear what the bigger vision looks like.
It's a very big goal, and who knows? We might not be able to reach it. This is hard work. We try really hard to work on this. We're every single day we're fixing these bugs, and just like before, where we believe the problem was easier than we thought, we probably still have rose-colored glasses on. Otherwise, we probably wouldn't be working on such a difficult thing. The longer term is being able to describe more complex places. So there are lots of places that are out there that you can't send a letter to. That could be a tree, a park bench, a pipe underneath the ground. There's all these other types of things that Placekey does not serve today and will almost certainly not serve in 2023 or 2024. But long term, hopefully, the hard part is figuring out, okay, what's the input? How do you do an input? The output's easy. Getting a place key on those things is easy. You can just assign something there. Having a service where you can match that data together is really, really difficult to figure out how you do that. And so that's the longer term thing that we need to figure out.
Well, Auren, this has been great, but I've listened to your podcast a couple of times now. And I've heard you ask this question, and so I want to end on this note. And the reason I like this question is because it makes you sound fantastic. Like I think, wow, that was a great question. And I watched the guests like, oh, that was a great question. How do I answer that? And the question is, what is the non-obvious thing about this that I'm not asking you? What haven't I asked you about Placekey, about, or maybe even in a broader picture, like this work, like bringing something like this to the world?
Well, there's a lot of projects out there that just require they require a great deal of intelligence and ingenuity, and that's important. But I think sometimes we overweight the intelligence and ingenuity, and that is important. So you do need those things, but they also just require just a ton of grit, a ton of sweat, a ton of hard work, a ton of just like keeping at the problem and doing these series of like 0.1% improvements and just doing a lot of these 0.1% improvements that just add up over time. And sometimes it's not as satisfying to do all these little improvements because it's hard to see that compound. You really have to zoom out to see these 0.1% improvements compound. They do compound, but it's really hard to see when you're in the midst of it. But if you have the fortitude to keep going, and a lot of the greatest things in the world have been built this way, if you have the fortitude to keep going, then you really, really have an opportunity to build something really exciting and great. And that's one of the things I love about Placekey. It is just a ton of grit. It's a ton of hard work. It's a ton of these like very, very tiny improvements, but they do really add up over time.
How do you see that? So this compounding nature of these small solutions, these small wins that you're having along the way. You keep saying they're really difficult to see. I've experienced that myself. Do you have a way of like seeing that? Like it's always easier to focus on the things you can't do yet. Do you have like a method, a way of sort of like reliving these small wins to keep yourself and your team motivated?
That's a good question. Probably we don't do a great job of that. So if any of your listeners have a good idea of how to do that better, I'm all ears. Celebrating the little wins is really important. And it's a good reminder to me to do that more often. So it's often where kind of like just, you solve some sort of problem and you just move on to the next thing without taking the time, even if it's a small amount of time to say, wow, we just solved something. We just made a whole bunch of people so much happier. We should celebrate that somehow.
Well, Aaron, I really want to thank you for your time. You've been a gracious, generous guest, and I really appreciate the conversation. And yeah, thanks very much for joining us. We've mentioned it a few times during the conversation, but placekey.io, if you want to try it out, I'll spend some time on the website. There's a lot of great information there. Anywhere else where we can send people?
Yeah, Placekey.io is great. And if anyone wants to interact with me on Twitter/X, I'm at Auren, Auren there.
And of course, your podcast, The World of DAS, is worth checking out.
Thank you. Appreciate it. Thank you, Daniel, as well. This has been a lot of fun.
So I really hope you enjoyed that episode with Auren Hoffman, CEO of SafeGraph, driving force behind Placekey. And I hope that you take the time to check out Placekey. There'll be links to that in the show notes of this episode. I'll also put a few links to Auren on LinkedIn and Twitter. He's a good follow on both, and to his podcast, The World of DAS. So thanks very much for tuning in all the way to the end. I really appreciate it. I'll be back again soon with a new episode. I hope that you'll take the time to listen in.